Oh, okay, let's go.
For class today, you should have reviewed the section on compound eyes in Chapter 3 of your text. Yesterday, we discussed eye structures called light spots, structures that can only sense light but can't see images as we do. Today, we'll look at one example of a compound eye by looking at the eye of a monarch butterfly. Let's look at the compound eye of the monarch butterfly in this drawing. The compound eye is a very interesting structure. Magnified, the eye looks a bit like a pincushion full of round-headed pins. The surface of the eye is curved and made up of thousands of ommatidia. Who can tell me what ommatidia are? Yes, Josh?
Aren't they lenses of some sort? Lenses on the surface of the compound eye?
Yes, that's right.
Yes, that's
right. The ommatidia are lenses, and they cover the surface of the compound eye. Now, how many lenses are there covering the surface of a compound eye? Joyce, are there 6? I think I read that there were 6. Well, you may have read something about the number 6, but 6 wasn't the number of ommatidia covering the surface of a compound eye. Who knows? Roger?
There are thousands of ommatidia covering the compound eye.
That's right, Roger. There are thousands of ommatidia covering the compound eye, not 6. Now, we said that the ommatidia are lenses, but they're not flat lenses. They're lenses with a number of sides. How many sides are there on each lens? Joyce? There are 2 sides?
2 sides?
2 sides on each ommatidium. Ommatidium. There are 2 sides on its lens. No, that's not right.
That's not right.
There are more than 2 sides on each lens. Who knows? Who knows how many sides are on the lens of each ommatidium? Yes, Roger?
Each ommatidium is covered by a 6-sided lens.
Yes, that's true. Here's where the number 6 comes in. It's the number of sides on each ommatidium's lens. It's not the number of ommatidia on each lens. Hopefully now we understand this. There are thousands of ommatidia on the surface of a compound eye. Each ommatidium has a curved surface with 6-sided lenses. And the 6-sided lenses allow each ommatidium to face a slightly different direction and sense a slightly different image. As light enters each lens, photoreceptors under the lenses send messages to the brain. The brain reconstructs the image of the butterfly's surroundings by combining the thousands of messages from each of the thousands of lenses into one image. Now, we're going to discuss what a compound eye sees, and I have 2 points that I'd like to make. The first point I'd like to make is that a compound eye can see movement well, but it does not focus well. Butterflies are very nearsighted, so their eyesight isn't very clear, yet they're remarkably able to detect movement. Have any of you tried to catch a butterfly in flight? Possibly some of you have been frustrated while trying to swat a fly? Researchers have known for a long time that insects of all kinds can sense movement very well. The compound eye allows insects to detect the slightest movement much better than our eye can, in spite of the fact that it doesn't focus well. Now, can you summarize for me what this first point is? Josh?
It's that a compound eye can detect movement unbelievably well, even though it doesn't focus well, and therefore doesn't see extremely clearly.
Yes, that's right. Now, for the second point about the compound eye. The second point I'd like to make is that it's now believed that a compound eye probably sees one image rather than a compound picture. At one time, it was thought that a compound eye saw a compound picture. Some thought that monarchs and other insects could detect movement well because each ommatidium registered 6 complete images. So the monarch saw some 6,000 pictures of the same item. This would be a bit like standing in a store and looking at a wall of TVs all tuned to the same channel. Every movement on the screen produces thousands of like movements. Now, most researchers think something different is happening. They think that a compound eye sees one image that is blurred because of the huge number of lenses in the compound eye. Because the eye senses light from so many directions, the butterfly detects movement easily. The slightest movement alters the light sensed in hundreds or thousands of the ommatidia, allowing the butterfly to react quickly, even if it can't clearly see what it's reacting to. Okay, I would like someone to summarize the second key point about the compound eye. Joyce, can you do that for me, please? The second point is that researchers used to believe that the compound eye could see only one image, but now researchers believe that the compound eye can see a compound image. No, it's the other way around. Try again. Okay, then. The second point is that researchers used to believe that the compound eye could only see a compound image, but they now believe a compound eye can see a single image. Now you've got it. Listen, that's all for today. Tomorrow we'll continue our study of eye structures. Please review the section in Chapter 3 about the human eye. I've put several interesting articles about recent research on the compound eye on reserve in the library. These articles are considered required reading in addition to the information in your textbook. As I think some of you figured out the hard way the last time around, tests in this course do cover both the textbook and the additional articles I assign. So please be aware of this, and please be prepared.